Bismillahirrahmanirrahim. Hello everyone. In previous tutorial, we have a model 2D frame in SeismoStructre software, and we performed a pushover analysis, and finally we saw some outputs and we did some interpretation. So in this tutorial, we want to use again the wizard uh, modeling option, which is quite fast, and we want to do this time a 3D model. Now we're going to select in the wizard, and we can select the 3D model, and we want to give the number of bays, number of stories, and number of frame. uh, just as a sample, we want to increase the number of stories to 5, and the number of bays, which is 1, 2, 3, and then this is the frames. I want to 3 frames, 2 bays, and 3 floor. The bay length is about 6 meters, the story height is 3 meters, and the frame spacing is also 6 meters. 6 meters, and the number of stories 5 meters. Now the cross section, we select the available cross section, and the loading is we applied a static pushover analysis and also uniform distributed load in H-beams. And okay, it asked me how much the shear force you want to distribute to the entire structure. I want 1500. Now here is the model which is created. This is 1 frame, and this is 2 frame, and this is called 2 bay. Now we can go to check from material. The material is used for long reinforcement rebar, steel mat, and for transfer also the same material. For concrete, use concrete mat. If I go to edit this material, you can see this is nonlinear behavior. The same for steel. This is the steel material which is quite popular. This is called the Monego 2-point steel model. For fiber elements, we usually use this material. So we created this 3 material, and next there is the available section is column, and this is beam. If I go to the column, and you can see this is the column using 50 by 40 centimeter and 0.25 milli thickness. You also can change, but just for a beginner tutorial, we want to do analysis and see the performance of this structure. Now we can go to the second element type, which element is used here. Yeah, the element is we called fiber moment, fiber edit. So we should select first this one. This is called section type is column, and the section is called fiber, which is the cross section is divided to fibers. We also have to apply plastic inch, but mostly the fiber also can represent the stress strain of the of nonlinear stress strain in the entire element. Also, we can, for the in case if we use entire structure fiber element or nonlinear behavior, with a nonlinear behavior that cause some unconvergence or divergence. So for this, we want to create some plastic hinges in the near to the beam column connection. So we're giving a plastic hinge automatically for this. Also, in case if you want to consider some sort of damping in the cross section, you can add it. But just this is simple. We have both fiber uh, beam column hinges. We got the node, and this is the entire created node. So the last node is here, and we can go to the element connectivity. So it says a 3D structure, so we need to create a element connectivities that actually already exist. We also need to add some constraint. You can see rigid diaphragm for each floor, totally 5, and restraint, which is giving the bottom of the structure, is fixed. Applied load, this is the one load is the incremental force which is applying to this column, and the second is the beam column load, which is applying in the z direction by -5 kilonewton. You can see if you go to edit, you can see beam 531, and the loading flows is a response spectrum analysis. The node is applied in this node, which is pushing to 0.30 meter or 30 centimeters. Now you can use which code you want to see the performance. So mostly this is a related code, design code. So we want to first talk A, B, and C, D. So it should perform like this. You can check the FEMA and also this code to see how the earthquake hazard is leveled. Now the code is defined for beam should be it's adequate or not. There's some technical theoretical background before you want to perform a pushover analysis for an existing structure. You should know this one. And now we can go to the another performance criteria. So this is the criteria which is defined for each element. So the crash yield of concrete, crash concrete fracture, also chord rotational shear. This is also giving, and we go to the processor here, and then before that we should save our structure. We should save pushover 3D. Now we want to perform run analysis, and it will ask you to so now it's starting to run, and this is the convergence. Here is showing, so there is not convergent but divergence, and also adaptive convergence, and again. So it means the structure got a very large failure in this moment, so it did not converge. Now what we're gonna do is we're gonna go to post-processing, and we can see the first thing. We can see the target displacement curve. So now you can see the blue one is the ideal elastic plastic curve. There is 2-3 method you can create this curve, and the gray one is the structure pushover curve. So you can see the structure is got failure until this area. Now we can see the parameter here is giving for the idealized curve and for the idealized parameter data. And now from this idealized parameter you can say the yield, the structure yield displacement is about 7.5 millimeter, and the force, the resisting force, so the structure with giving criteria can resist this force. Now we can based on this resisting force, we can design the structure. And here is the data. Also, we can go to some shape deformants, and we can let's go to in this direction, and we can go to the edge step, and you can see the pushed. And as well as we can also see some other action effects, such as the movement, the beam, and the shear force. And also we can go to scale, and this is moment 2, moment 3, each element. You can see, yeah, you can go to also see the shear in two. This 2 3 is this one. Okay, now you can see the shear. So after this finished, you got the result, and then you will go back to retrofit. So you will see the present uh, earthquake requirements, and you will get the base shear, and then you will design this structure again. So like this, you will conduct your study, uh, and you will finish your work. Okay, this is the end of tutorial, and the next tutorial we will do time history analysis, and also we have another type of, or maybe around 5 or 7 sort of design is here. And also we will create the structure, such structure manually, and we have a lot of coming tutorial. So see you next time.